Hello, everyone. Welcome to Universe 2020, and welcome to your very first professional services workshop. Today, we'll be learning how to automate your workflows with GitHub Actions and GitHub Packages. So a little bit about myself. My name is Rowena, and I'm an implementation engineer on the professional services team. So on my day-to-day basis, I talk to GitHub enterprise customers from all around the world to help them how to use and maintain their GitHub enterprise instance. So today, I hope I can bring some of my experience and expertise to help you learn something new today. So with my co-presenter, Stefan, I'll hand it over to him and let him introduce himself.
Thank you, Ravenna. Hi, everyone from my side. My name is Stefan Berkenos. I am a solution architect on the professional services team. And in my daily work, I help customers develop software using GitHub. And a common ask is how to improve their software development lifecycle by automating common tasks using actions. So with that said, I'm very excited to join Ravenna today in helping you start out automating your own workflows. Thank you. Back to you, Ravenna.
All right, awesome. So from today's workshop, we hope to achieve a few outcomes. The first one being, we hope to help you understand how GitHub Actions and packages can fit into your software development lifecycle, how it can add value to it. And we also hope that you can come away with a better understanding of the components that make up GitHub Actions and GitHub Packages. So I understand that maybe many of you on this call today have very rich experience and expertise on GitHub Actions, given that it came out a year ago. However, if you're on a one-on-one level, I got you covered. We have a one-on-one level overview of GitHub Actions. And even if you're an expert, we hope that you would go into the workshop with the same level, same understanding, same use of terminology. So regardless, I hope that this kind of level set everyone going into it. Finally, we're going to get our hands dirty, of course, and we're going to learn how to build our own workflow so that by the end of this workshop, you should be able to walk away with knowledge and confidence to learn how to automate your pipelines. So let's jump right in. First of all, why even care? Why even learn about GitHub Actions and packages? How does it fit into your day-to-day work? Well, maybe during, if you were here during Universe on day 2, our COO, Erica, talked about how it takes about 23 minutes to get into that Zen flow, that zone that you're really into your work, you're just cranking work away and nothing else matters, you're not distracted by anything. So it takes about 23 minutes to get into it. And if you're distracted by something else, or if you need to switch contexts, it takes another 23 minutes to enter it again. So it's important to think about how it can help reduce the noise and reduce the tasks that forces developers to kind of context switch throughout the day. So this diagram, maybe a lot of you are familiar with it. This is the diagram that shows your entire software development lifecycle. I'm just going to call it SDLC from here on, just because it's a very long phrase to talk about. So SDLC for short. So along this lifecycle, developers may have to switch from different tools, to carry on different tasks. Most of it might not even be directly related to your code. Maybe they're in Jira, maybe they're doing administrative tasks. So there's a lot of context switching going on, and we want to think about how we can implement automation at every phase and let the bots do the work so that you can focus on developing code and just generally make life easier. So from each phase, at the planning phase, there's issues, GitHub issues, and GitHub project boards that can help you out with that planning phase. I recently talked to one of my customers, and I was really impressed with how they were thinking outside of the box, not just using GitHub Actions for CI/CD, but they had this idea of using GitHub Actions to create issues automatically. So they have this web application, and they also have this feedback form. What they had built was, whenever their customer have any feedback, they can create a form, they can send their suggestion in, and when they click send, it automatically hits our GitHub API and creates an issue for them directly in their repository so that developers can just start cranking work away. So I thought it was pretty genius for them to even think about how to use actions outside of the box, even before the planning even begins. When it comes to code, there's a lot of features in place already, such as code review, And if you were here on the first day of Universe, it was announced that we have a new feature called Auto Merge, where as long as your pull request has met all the criteria, the pull request will automatically merge for you. And some ways where you might want to use GitHub Actions to help automate that, you might think about maybe auto-labeling your PRs or issues, things like that. From the build and test phase, it should be pretty straightforward. This is where your CI/CD starts to come in. So when you're thinking about compiling, building, storing artifacts, you can do that with GitHub Actions and packages. When it comes to the testing phase, using GitHub Actions to automate your test suites from unit tests all the way to regression testing, using linters for code quality, using our CodeQL for finding security vulnerabilities, downloading, installing packages as part of your workflow using GitHub Packages, all can be very powerful when it comes to accelerating their process and kind of increase velocity along your SDLC. Release and deploy, this is also pretty straightforward, publishing your release, uploading artifacts to your release, and then finally deploying your application either on-premise or to any of your cloud providers using GitHub Actions. These are all ways that you can use actions and packages to automate your process along the way. So maybe you might be thinking about, hey, I have all these tools in place already. I'm already using Jenkins, I'm already using Jira. So what is the point even why do I need to migrate to GitHub Actions if I already have all these tools? Well, one thing is GitHub Actions, in short, allow you to build CI/CD capabilities directly in your repository instead of using CI/CD integrations. So this gives you the freedom to automate and accelerate your process all along your software development cycle. So let's dive into actions and maybe you'll have a better idea of what I'm saying. At a very high level, what are GitHub Actions? Actions allow you to automate, customize, and execute your software development workflows. They are stored as code, which is really nice. It means that you can version control it, you can share, reuse it for easy collaboration. It comes with live logs. And again, new feature that came out that was announced during Universe, actions now come with a visualized workflow execution. So maybe if you're using Jenkins, this is very similar to like Blue Ocean, where you can kind of see each stage going on, but this time it's directly in your repository. I really like the live logs feature because in the past, I personally use Jenkins. I don't mean to hate on Jenkins or anything, but it's just an example that is very salient. But I have to push my code, go to Jenkins and see the logs. And if something breaks, I have to come back, push code. And then when I go back, sometimes I get logged out. There's something wrong with my server and all that kind of stuff that I think about. Now with live logs, everything is in my repository. I get instant feedback and I don't have that kind of silo going on. So if anything breaks, I can immediately just change it in my repository. GitHub Actions also allow you to build matrix if you want your workflow to run tests across multiple combinations of operating systems, platforms, and languages all in the same workflow. And then finally, you have the option to either use our own servers, which is what we call the GitHub hosted runner, or you can use your very own, which is what we call the self-hosted runner. So let's take another step deeper into GitHub Actions and understand the components that make up GitHub Actions. From the start, you start with an event. The event, it will be the fire that sparks this chain reaction. It will be triggering the workflow. So events is a specific activity and it triggers the workflow. The workflow is going to be made up of one or more jobs. Each job contains a set of steps, and each step is an individual task that can run commands in a job. A step can either be an action or a shell command. Actions are then referenced in the step. This is going to be your smallest building block of the workflow. The action that you reference is also portable, meaning that you can reuse it somewhere else. You can put it in the repository, put it in a workflow, whatever you want to do. That's what I mean by portable. And then the last component of GitHub Actions is the runner itself. The runner is the environment where the job is executed. Each step in a job executes on the same runner, allowing the actions in that job to share data with each other. You can use a runner, again, either from us or you have your own. A runner listens for available jobs, runs one job at a time, and then reports the progress, logs, and results back into GitHub. So how does this work in practice? Well, first you start with a YAML file, call, whatever you want to call your workflow, but it's going to be in YAML syntax. And then you're going to put this file in a folder called .github/workflows. This is going to be in your repository. You create a folder, create this file, put it in there. It will come with the following syntax. This syntax will have events, jobs, runner, the steps, and then actions, secrets if you have secrets going on. So overall, these are the basic components of a workflow file, the YAML syntax that will allow you to automate your process. So let's look into each individual component a bit deeper. We're going to start with events. Things that you can use as part of the events. One is going to be webhook events. These are your traditional GitHub events, like when someone opens a pull request, when someone approves a pull request, opens an issue, close issue, or whenever someone pushes to the repository. So in this example that I've highlighted, I use an event where whenever an issue has been closed, reopened, or labeled, please trigger this workflow file. The second type of event is called schedule events. This is where you use a cron job, and in this example, it's going to be run every 15 minutes. The last type of event, if none of this worked for you, you can think about manual events as well. One of the manual events that you can use is called workflow dispatch. This is just one example. What this means is that if you have this event in your workflow file, it will come with a button and you can click, run workflow. This is going to be pretty manual if you don't want your workflow to run automatically. Next, we have the runners. If I want to go with the GitHub hosted runner, it's going to have the following hardware configuration. It's going to have the following operating systems as well, such as Windows, Linux, and Mac OS, and it has tons of software installed already. So on the right side, where my syntax is, this is how I would reference a runner that I would like to use in my workflow. If you don't want to use any of that, there are good reasons why you might want to consider a self-hosted runner. Some reasons are like maybe you have a job, a larger job that you need to run, or maybe you need your job to run in a specific environment where you require a specific version, certain type of software that is not offered by GitHub. Or if you want to run your actions in a private network, self-hosted runners are a good reason to go with that. So when you install a runner onto your repository, GitHub automatically creates labels for them, or you can create your own labels to associate with these runners. What I mean by labels is that once you have tags or labels associated with your runners, you can then reference them in your workflow to tell the workflow which specific runner that you're using. And then we come to the star of the show, the actions itself. So actions are reusable units of code that can be referenced in a workflow, and GitHub runs them in Node.js runtime or in Docker containers. There are three types of actions you can reference. The first one being you can reference an action coming from a public repository. So an example I have on the right side in the syntax, I'm using an action that's coming from an organization called Actions, and the repository is called Checkout, and it's at version 2. So this is an example where I'm using someone else's action. It could be your own, but if you put your action in a public repository, this is how I would reference it. A second type is, let's say I don't want to put it in a public repository, or I don't want to use anyone else's. So I'm going to build my own action, or I bring an action into my own repository where your workflow file is. So in the syntax that I have highlighted here on the right, this is how you would reference an issue coming directly from a repository, coming from the root folder. This is sometimes called a local action as well. And then finally, you can also use a published Docker container image on Docker Hub in your workflow. So we have gone to understanding GitHub Actions from a very high level, understanding the components, and then we move on to talk about the syntax of a workflow file and what are the elements you need in your workflow file. So let's just zoom out a little bit and kind of have a more abstract idea of GitHub Actions. Essentially, events trigger workflows, and your workflows would reference an action. altogether is what typically, people refer GitHub Actions as. When people talk about GitHub Actions, they usually refer to all three components. They talk about the workflow file and how to build your jobs and your steps. Not very often do people actually mean the last component of actions, meaning that if you're thinking about writing your own action, that's not what the focus of this workshop is about. Writing your own action is a kind of a separate conversation. We'll get into it a little bit, but it's kind of a little separate conversation. It's not going to be our focus. The purpose of this workflow is to allow you to master that workflow YAML syntax that we're talking about. You need to come away with at least that knowledge to learn how to edit that and be a master of it, and then learn how to reference actions. However, to satisfy your curiosity, if you're wondering what it's like to write your own actions, here are some things to think about. If you're thinking about writing your own actions, you can either do it in JavaScript or create Docker container action. So a container allows you to have very specific environments, right? Like you can have specific versions of dependencies, tools, software, all that kind of stuff. So if you're thinking about writing an action that requires it to run in this specific environment configuration, then Docker container would be an ideal situation for you to write an action in. So that if you're thinking about having someone else consume your action, they don't have to worry about the dependencies, which is awesome. On the other hand, there's also JavaScript actions. So JavaScript actions run directly on a runner machine. Using a JavaScript action simplifies the action code, so it executes kind of slightly faster than a container action. The next thing to think about is that your action needs to be defined with a file called action.yaml. The action.yaml file is a metadata file. In this metadata file, it defines the inputs, outputs, and the main entry point for your action. So in this example that I've highlighted, in this specific action requires an input parameter. So an input parameter allows you to specify data that the action expects to use during runtime. One thing that you don't really see in this action.yaml file is the output parameter. That is an optional parameter to declare. But if you're thinking that you need your action to output something that will be used later on in a workflow with a different action, that will be a parameter that you would include. So best practices for writing your own actions. This is going to be very similar to a lot of dev practices out there. You want to use chainable actions as opposed to monolithic actions. So that's easier to debug, stuff like that. We recommend using release management to control how you distribute updates so that whoever is consuming your action, they're not using your action from the default branch. They have the specific version that they're looking at. So when you are writing your own action, it's going to be the same deal like any open source projects out there. It needs to have really good documentation like readme.md and contributing.md so that people understand how to install your action, how to contribute to it. Proper action.yaml metadata, that goes without saying. And finally, you want to add your action to the marketplace so that other people can benefit from the work that you have done. So I talked about marketplace a little bit here and there. So let's talk about that some more. Let's look into what marketplace actions are. Sometimes these actions are being referred to as third-party actions, and they live on the marketplace. So let me show you what that looks like. Okay. So this is, you guys can see my screen? Awesome. So with GitHub Marketplace, I can look for actions from companies that I might be using. If you see a little blue check mark, that's kind of the VIP symbol on the internet. That's when you know it's legit. This is what we call verified creators. It's verified by GitHub. And you can find a bunch of them that relates to the software development lifecycle that I've been talking about. Deployment, for example, could be one. So let me click into deployment. Let me look up Azure, because maybe I need to deploy to Azure. And here I can find things that have already been written by Azure. So instead of magically knowing how to deploy to Azure Container, I can just come in here and look for stuff that is already written by Azure themselves. And they already did the legwork for you. All I need to do is just use this action and reference that in your workflow. So in their README file, they kind of show you how to do that. I can see that all I need to do is reference that, right? So that's one example. That's for deployment. For project management, for example, let me just remove this search. I can see a lot of Jira actions here as well. So maybe if you're using Jira as part of your project management tool, this could help you maybe reduce that context switch that we're talking about. Maybe bring some of that information into GitHub instead of forcing developer to go to another place, do some Jira stuff, come back to GitHub again. Let's see what else. I think it's really important to plug in the work that your coworkers are doing. So I'm going to talk about Superlinter because it was built by a bunch of my coworkers. They're really awesome. And this is super popular because it has 6,000 stars. Basically, the Superlinter, it links for code, and this is all the languages that it supports. It gives you a really quick high-level overview about how to use it, how to reference it in your workflow. And I can see here, this is how I would use it. Okay. And if you're curious about the source code of this action, I can go into the links here, click into Superlinter, look into the actual source code repository. I can see that it comes with the action.yaml file. This is what I mean by writing your own action. If you're someone that writes your own action, you need to come with an action.yaml metadata file. And another good practice that you see here in this repository is that it has good versioning going on. So you can see in the release, it was tagged 7 days ago. That shows you, it's pretty active. So it does use some of the best practices that I was talking about. Okay, so let's talk about how does action look like in a repository. So I'm going to go over to a repository that I have. From this repository, you can see that the most popular language is JavaScript. That kind of is the biggest component of my repository. If I go into the Actions tab and click on New Workflow, immediately what I see are suggested actions that relates to my repository. So these are most relevant to JavaScript code base. So this is what I see immediately. So let's say I don't want to go with any of the suggested workflows. I can also click on set up a workflow yourself right here. And then I can then see the marketplace from here as well. So I don't need to always go to the GitHub marketplace to grab something. I can search the marketplace directly in my repository. So let's say if I go into Superlinter, I found it and I click into it, I get some information here. And so I can think about bringing that into my workflow file. Okay. So again, it comes with two perspectives. If you're someone who wants to leverage the community work for GitHub Actions and use third-party actions from the marketplace, I would definitely encourage you to go over the workflow syntax for GitHub Actions, kind of learn what are some parameters you need to declare in your workflow. On the other hand, if you're creating an action, if you're someone who wants to contribute to the marketplace, then I would encourage you to focus on the help documentation on how to create your own action. Okay, so that being said, let's go back to our keynote. All right, so I showed you the marketplace action. Some of you here may be repository admins, and you might be wondering, hold on a second. So you're saying that we're going to go out and grab all this different actions coming from different places. Like, I don't like that. I want to at least audit or make sure that all the actions coming in are secure and they're in good hands. So what you can do in the repository settings is that you can go in and say what type of actions you want to allow in your repository. You can say that you want to allow local actions only, meaning that you are only allowing actions coming directly from your repository. Or you can say allow select actions, either they're actions created by GitHub, actions by verified creators, the one with the blue tick, or you can say you want specified actions at a specific version. So that's how you would manage repository actions coming in. So let's move on to GitHub Secrets. That's because it's also another component of actions. GitHub Secrets is essentially a built-in secret store specifically for GitHub Actions. Secrets are encrypted environment variables that you create in a repository or organization. Secrets are encrypted before they reach GitHub, and they remain encrypted until you use them in a workflow. So you can manage secrets through the API. That means you can create, update, or retrieve any information about encrypted secrets. So again, you can have secrets at the organization level, or you can have it at the repository level. At the organization level, you can define where you want the secrets to be used. So you can say this secret's only for this one repository only. No other repositories can use it. But what's nice about having secret at the organization level is that it's just one place, one place that rules them all. So if you need to update a secret, you can just go into this higher level place, update it, and then all the repositories will get the updated secret. On the other hand, you can also have secrets at the repository level, which obviously is scoped to the repository itself. It can override organization secrets. So in this example that I've highlighted, I have secrets named exactly the same at the organization level and also at the repository level. And if I do it this way, then the repository secret will override the organization secret. So how do you use secrets in a workflow? I'm back again into my workflow file. This is the YAML syntax that you were looking at previously. So to use a secret in a workflow, you would access them using the syntax that I have here. So whatever secret name you have, you would just access it with the syntax. On the other hand, GitHub also creates a token automatically for you so that you can use that in your workflow. The way GitHub does this is that it installs a GitHub app on your repository, and this token is used to authenticate on behalf of the GitHub app installed on your repository. So this means that the token's permission is limited to the repository that contains your workflow. Again, in the highlighted syntax that I have on the right, if I'm using this token that's automatically created, this is the syntax that I would use. The secret name is called GitHub token. So when you run your workflow, GitHub would fetch this token for the job, and the token would expire when the job is finished. And what if you already have some type of secret store that you're already using, maybe from HashiCorp or Azure Key Vault? Well, you can use their GitHub Actions to still continue using the vaults that you already have instead of using the built-in secret store. So again, leveraging the power of community actions to help you out in your automation. So that being said, I'm going to hand it over to Stefan, who will go over GitHub packages. Oops.
All right, thank you, Ravenna. I'm just going to share my screen quickly, and then we will keep going. So, all right. If one of my fellow moderators could give me a thumbs up if you see the GitHub packages front page, awesome. Okay, that was really interesting stuff. Thank you for that, Ravenna. I just wanted to highlight before we move on to the next topic that there were a few questions in the Slack channel. Thank you very much for that. Keep them coming. There was one specific questions about GitHub Actions and how you would kind of design principles about how to modularize these actions and so on. And I just wanted to verbally as well, like second the input from Thomas and Stowe and Evgeny about, still respecting the software design principles of separation of concerns and all these kind of things. So there's no one size fits all, but it's definitely something that is specific to your context. And when it comes to like, when do I build a separate workflow versus having all of my actions in one workflow, it's basically about, thinking about like, which parts do I want to reuse and which parts do I want others to make use of and so forth. So it's not that much different than developing software as you're used to already. So speaking of separation of concerns, now that we have talked about automation with GitHub Actions, let's move on to the next topic, which is GitHub packages. Because another aspect of software development is also how to package and distribute your code, either as an open source project, an inner source project, or if you're just working in a smaller team, essentially so that others can pull and reuse your code, including all of the metadata and the dependencies that are needed to run your code. And most people are familiar with package managers already. We'll get into the details of that in a moment as well. And you probably use that actively as part of your SDLC. So the good news is, along with GitHub Actions, is that you can now do all of this stuff using GitHub packages. So if you look at the screen here, we can see some package managers that you might or might not be familiar with already, but we have things like NPM if you do Node projects, NuGet if you do .NET development, Ruby, of course, Gradle and Maven for Java development, and of course, Docker containers. So I'm guessing that a lot of the people on this workshop already know some or perhaps even all of these already. And the concept of GitHub packages is essentially to host and manage and share all of your packages using your GitHub account. So you don't need to multiple accounts. A lot of software projects, they don't use just one language, right? You maybe have different components, microservices or something of that sort that are developed in different languages. And that also means if you want to package this code and distribute it, you also need to have accounts and manage credentials and that kind of stuff for all of these different package managers. In addition, if you have everything behind the same GitHub account, you can leverage existing features of GitHub, like, for example, access permissions. Who is able to access, pull, and even contribute to my code. And you can also host multiple packages in the same repository. So even if you do development in different languages, you can push packages to that same repository. So the next point is then also publishing. Part of the magic behind GitHub packages is how seamlessly it integrates with GitHub Actions. So you can build and publish your package using either a community action, which Rovena already showed you on the marketplace, or you can build your own. And if you go to that Actions tab, you will see a lot of these starter workflows, right? And one of the starter workflows that popped up in Rovena's demo was, for example, the publish Node.js package. So you could just click on that and you can get going, right? If you happen to do your project in JavaScript using Node. And additionally, you can also have workflows that actually listens to package events. There is an event called Registry package. And this is an event that allows you to trigger workflows whenever a package is published or updated. So you can actually chain together workflows that serve different purposes, separation and of concerns and so forth, by using this package event as well. And the next part is API support. A lot of our features in GitHub you can do via the API in the same manner as you would do it in the user interface. And that also counts for packages. There are some constraints, but essentially you have existing API endpoints that you can invoke for our GraphQL API. You might be familiar with GitHub APIs, and we have two versions. We have version 3, which is our REST API, and we have version 4, which is our GraphQL API. And using our GraphQL API, you can both retrieve info about a package, and you can even delete specific package versions using that same endpoint. In terms of URL, if you use one of these package managers already, then you already have a target URL, right? That you push your packages to. For GitHub packages, it's very simple. It's simply the package registry.pkg github.com, followed by the owner, which might be either your user handle or your organization name, depending on whether you have your repository in an organization or behind your personal account. Then your repository name and your package name. So for example, for NPM, this would be npm.pkg and so forth. And then the last point on this slide before we'll have a quick look at the GUI is that it inherits the permissions and the visibility from your repository. So for example, if I have a private repository and I build and publish my source code from that same repo, then the package will also be private. and vice versa for if I have a public repository. If I publish a package from that repo, then that will be a public package. You might notice that we are missing a few things on the right-hand side, such as Python, PHP, and maybe even generic packages, but we'll loop back to that at the end of the workshop. And for Docker, we'll also have our own little slide on that coming up later. Before we go there, I just wanted to show you what this looks like in the GUI. We'll also have a bit of demoing on this part as well coming up, but just a few key points. So what I'm looking at here is an NPM package. And if you have used npmjs.com, for example, then you already recognize a lot of this metadata. For example, you would have the name of your package. You would also have some code snippets that tells you how to install this package as a dependency in your own project. And then also a description on how to actually use and consume your package. And one thing to note about the description actually is that if you have a README file in your repository, a README markdown file, then when you publish a package, that README file will be set as the package description by default, but you can of course edit that description as well later on. Second thing, a few more data points here. You see who the owner is, you see when it was published. You can also see the SHA commit that this package points to, the version number, and the tarball file, which you can download as an asset. Download activity as well, if you would like to monitor how popular is my package and so forth. This is where you would do that. And of course, you're probably gonna end up having multiple versions of the same package. So you can both view and manage these versions directly in the UI. All right, so now we had some basics about packages. So how to actually use this in your workflow. It is pretty easy. And if you're coming from an existing package manager like NPM, then you could essentially switch over to using GitHub packages by changing the target URL. Because we have starter workflows for different ecosystems, not only NPM, also for Ruby, for Maven and Gradle, and so forth. So if you go to that Action Top tab again, search for it, then the chances are you are going to find something that suits your need. You can also reuse existing workflows that you might have in GitHub Actions by updating the target URL, which we showed on the earlier slide. And one of my favorites actually is that it's so easy to get started because you don't even have to create a new personal access token. You can just use the GitHub token, which was briefly mentioned during the secrets session, which has the appropriate scope to publish a package in that repository. So you don't even have to, set up your organization or repository secrets or something like that. You can just use the GitHub token. And that is what we see on the right-hand side here. So this is a workflow file that listens to a push event, and it listens to push events on the branch main. There was a question in Slack earlier whether you can actually have some more granular control over which events we want to trigger the workflow on. One of the questions was, can we specify this to a specific branch? And the answer is yes, as you see here. And this workflow has one job, which is essentially to publish to the GitHub package registry. We see that it runs on a GitHub hosted runner on the Ubuntu latest, and it contains 3 steps. The first one is just to check out the repository, and the next 2 are to actually publish the package. So we have one action and one command that we are running. The first one is action setup node, which sets up our environment. And this is where we specify what is the target URL for this package. And here we see that we have, again, like I showed before, npm.pkg github.com. And on the next step, we do something that I also do a lot, which is really convenient with workflows. You can, since the GitHub hosted runner comes with a lot of pre-configured and installed software, you can just run terminal commands directly in your workflow file. So in this case, because of the GitHub hosted runner coming pre-installed with NPM, I think on Ubuntu latest is NPM version 6.14 or something like that. I can just say in this step here, run npm publish. And that's it. And I just need to specify which token I want to use to authenticate. And I can use the GitHub token. And this will successfully publish a package as part of my workflow file. So it's pretty cool stuff, and it's fairly lightweight, and it's really easy to get started. So moving on to the GitHub container registry. We talked about packages before, but what about containers? Rowena also mentioned you can create your own actions, for example, either using JavaScript, or you can write an action in a Docker container and create an image. So it's not necessarily an action, but if your source code, you want to pass a container image, how do you do that? Well, you can do that with GitHub container registry. And some of you might have already used this before, because before we also had Docker support in GitHub packages, but this has now been separated into two different features, let's say. So we now have GitHub packages and we have GitHub container registry. But conceptually it's the same. So we want to host and manage our packages behind the same organization or account. For those who are not perhaps familiar with containers, essentially it's a lightweight executable bundle of software. It's very fast to spin up and deploy. It's often contrasted with the alternative of using virtual machines, but containers are faster because you don't have to bundle all of the OS specific stuff and the hardware and things like that. So it's typically a lot smaller in size and therefore also faster to spin up. And these are the artifacts that you can also use, that you can store in GitHub container registry. The hostname is new. So if you came from using GitHub packages for storing your Docker containers, you will have to update your URL. And the URL is ghcr.io. And another difference with GitHub packages is that it has fine-grained permissions and visibility. That means that you can actually define for a specific container who should get access, what sort of access. Should they have just read or write access, or maybe even admin? And I can also decide, even if I create an image from a private repository, I can still make that image public. So this is also partly why GitHub container registry and GitHub packages were kind of separated into two features, because these are needs that are often specific to containers. And this is now possible with container registry. Another difference, it does require a personal access token. You cannot use the GitHub token to build and publish a container image, unfortunately, at least for as long as this feature is in public beta. But there might be changes there as well. So, so we'll see once it gets to general availability. And before we move on, I just wanted to highlight a few really great marketplace actions you can use to build and publish your image. Here we use two actions. They're both built by the Docker organization, actually. And the first one is just for logging in to the container registry. And here we specify the URL and our username, which we pull from the workflow context. So in this case, when we trigger the workflow, that workflow has access to certain data about its context. And one of those contexts is, okay, so which repository am I running this workflow in? And I have access to this payload, so I can just pull, using this syntax here with the $, the repository owner. So I want to log into GHCR using whoever is the repository owner, which in this case would be myself, right? And as the password, as I mentioned before, you cannot use the GitHub token. So I have set up a repository secret called CR_PAT. And this will then authenticate me to GHCR. And the next thing is then to push the image. And here I use another Docker action called build push action, which just takes a few input parameters, such as the context, where to locate the Docker file, and also which tags to use. In terms of the GUI, it's quite similar to the packages that I showed before. Just a few of the same metadata here. For example, the code snippet about how to pull your image, the name of the image, and also the list of the different versions. And on the right-hand side, you have a button that you don't have for GitHub packages, which is the package settings. And this is where you can specify, for example, you can invite teams or users to gain access to your image and download statistics and all of that good stuff. Okay, so that was, I think, a lot of talking on my side. I think it's time to maybe show some of these features that we've been talking about for GitHub packages. So what I'm going to do next, I'm going to show a workflow that publish an NPM package, and same for a container image, and we'll talk a little bit more about that. All right, so then I'm going to change my screen here, and I will pull up. Oops.
And Stefan, there was one quick question that might be good to go over now before you start the demo.
Mm-hmm.
So the question came from Matt, and he said, is there a recommended way to migrate existing versions of a package to the GitHub package registry from a previous registry? So as an example, if I had like v1.0, 1.1, 1.2 in an NPM registry, how can I migrate those to GitHub package registry?
I think that would also depend on which package manager you're already using, because with GitHub, for example, you can pull a package. So there's nothing preventing you from pushing that same package up to a different package manager in this case. But for example, for NPM, I'm not sure about that, to be honest. Maybe we're going to have to loop back on it. I haven't encountered that use case before. So maybe we'll have to come back to it at the end of the workshop.
Yeah, Evgeny and I answered it partially, at least in using NPM as an example, and just basically stating to change your local configuration to point to the GitHub package registry, and then you can push each individual version package that way. But I agree, it probably will depend on what package registry you're using and all of that. So
yeah. I will mention that in the same workflow, you can push to multiple registries, right? So in the previous workflow that I showed, there's nothing preventing me from pushing to both npm.js and to GitHub packages. And the same for container images. I can push to both GitHub and to Docker Hub, for example. So if you in a transitory phase, maybe that will be kind of your workflow. But it depends on your context, and we'll make sure to come back on that at the end. Thank you for the questions, though. Great stuff. All right, so with that, let's have a quick demo. We'll do this demo, and then we will move on to the hands-on exercise. I guess a lot of you want to kind of try this out yourselves as well. So we are getting there. Hang on, and we'll be there in a moment. I just wanted to kind of show a kind of a live session here where we demonstrate some of these features. And I just want to get a thumbs up first from one of my moderators that you see my Chrome.
Yeah. Might want to make it a little bit bigger, just a little.
Make it bigger. Thanks for that.
Yeah, that's good.
How is that? Okay. Good stuff. All right, so let's start looking at a workflow that I want to use to publish an NPM package. The way I'm going to do that is to first, I'm just going to click on this action tab here, actually. So I have, first of all, my repository. It's behind an organization that I call Stabby Actions packages, right? But feature-wise, this is exactly the same, whether you have it behind your organization or your personal account. And what I see here is that I have 4 workflows. Two of them has this strange symbol, and I just wanted to address that in case some of you are wondering, what does this mean? This means that the workflow is disabled, and it's maybe just something to point out that if you have a lot of workflows and you see like one day, okay, we want to get rid of this workflow, but we're not really sure. We just want to kind of pause it for a moment. You can do that by simply disabling this workflow, and that will essentially suspend it. So it will no longer trigger it, and you can also re-enable that workflow at any time, right? So that's what you see here for this suspended workflow, that I can just enable this one again once I decide that I need to use it. So we have one workflow called publish to GPR. I will not disable it now. I will just go to the to this run here, and I want to have a look at the workflow file. So what is this workflow actually doing? So let's have a quick look. First of all, it has a name, publish to GPR, and it reacts on push events to my main branch. And additionally, you can add some more granularity to the trigger. So in this case, I just want to trigger this workflow if there is a push to or a change to a file package.json. Right. So this essentially means, hey, I don't want to publish a new package unless there are actually any changes to my node project file, which is my package.json. And then I have one job, which is to publish, runs on a GitHub hosted runner. It checks out the repository, sets up my environment with node version 12, and it specifies the URL that I want to publish to. Then it runs a few commands, right? So we talked about earlier, you can run commands directly in your workflow file. This runner comes pre-installed with npm. So I can just run npm CI, npm run build, which will run a build script, which I define in my package.json file, if I have a script present. And then lastly, publish. And I authenticate using my GitHub token. So if I now go back to my code and just have a quick look at my package.json file, I just wanted to show a few metadata points that are important to highlight. So in package.json, that is, I mean, if you do Java, for example, you might use, this will be maybe your Palm XML file, or if you use Ruby with the Ruby gems and so on. I know that Node and NPM is getting all the love today, but JavaScript is the most popular language on GitHub, at least according to the latest report. So chances are a lot of you have already seen this before. But anyways, in package.json, we see our name. And here we need to specify who is the owner of this package and which repository do I want to publish this package to. And of course, we have a version. And these two metadata points are used by GitHub packages to actually publish it, right? And we see I have one dependency already and some other data like the repository URL and so forth. All right, so what we can do now is to actually go to my VS Code, and we'll do some changes, because we remember that we only want to publish a new package if you have a change to package.json on the main branch, right? So here is my project. This is the same repository as we were just looking at. And what I want to do, I have my source code here, and I'm just going to make a small change. This is a fairly simple code snippet in JavaScript, granted, but so it might not make it to the top spot of GitHub packages in terms of downloads. But let's go ahead and make a change anyways, because I just wanna trigger a new package. So what I'm going to do, I think this the exclamation mark is a bit too aggressive, so I add some points here instead, which then highlights that I have a change here, and I will stage and commit that change. Oops. Right. So I add that change, and I can see that now I have one change ready to be committed. So I will commit that change. I will sign it. I'll give it a message. And I will just say improve code comment, right? Okay, so that is committed. And then I also need to update my package.json file. So here I just want to use an npm command as well, which is called npm version, because it will update the version and it will also commit that change by default. So I will say npm version, and we have used semantic versioning. So we have the major, minor, and patch version. I would just update the patch version. All right. So this will also add a tag, by the way. So if I go back to my package.json file, we see that it bumped it to 1.4.1. And if I now look at my Git log, oops, I can see that I have two commits. I have the head here pointing to main with a tag version 1.4.1 and the previous commit that I made to my index file. Okay, great. So let's push that back up. And what I should see after that is that my workflow is triggering. So let's go back here. I will click on my actions tab. I have a new workflow that was triggered. Rowena mentioned this, by the way, with the visualization of the workflow. Now I just have one job, so you only see one box, so it might not be super interesting, but if you had a more complex workflow, you would see those tied up in a chain here. All right, so that succeeded. As we can see here, it ran all of the scripts and it published my package. So that means if I go back to my code tab here, I can see that I have a package link on my right-hand side. And if I click on that, I already had previous versions of this package, but now I published a new version. So I won't see a new package, but I would just see, okay, I have a new version of that. And this is where I can really start to use my package as well. Like I can look at all of the metadata here, which I showed you in the slide as well. I can see the README, which has automatically been added as a description, but I don't really like that description. For example, it has some relative links to images and so on that are not really good. So I'm just going to delete that. And I also don't need to include the badges, right? So I just preview that and okay, good enough. Okay, so I edit my description. And then, yeah, last thing I want to show here is actually to manage the versions. I have a lot of versions of this package and I can go in and delete individual versions if I want to do that. So great. The last thing I'm going to do for NPM is to go back to my VS Code, because that is just half the story, right? I publish the code, but I also want to reuse it. And just to show that this actually works, I want to actually install my package and make use of it. So what I'm going to do in this folder here, I'm just going to initiate a new node project with all of the defaults, which makes a package.json file pop up here. Good stuff. And then I'm going to install that package as a dependency, right? So now this one is basically empty, but I go back here, I go to my package, I copy this link, and I run the command. I'll wait for a moment. All right, cool. So now we see in the dependencies field here, we added our package as a dependency. So I now have access to reuse the codes that I have available there. All right, so the next thing we're gonna do is to just create a very simple JavaScript file that we call index.js. Okay, so I go back here. This is my JavaScript code. And I will just I also have to add this as a explicit dependency. So I will say I would say in JavaScript syntax, const print me equals require and which, oh, okay, thank you, IntelliSense. It added that for me. Right, so I added that now in my code base, and then I want to check if it actually works, right? So if I went back here to this code, it's basically just like outputting something to my console, and I need to feed it one variable, which is just the text, a string, basically. So let's do this. Let's just do print me, and I want to ask, does this work? Cool. And then I will run that code. So, all right, and it prints it, right? So it's if you use Node, then this is basically no change to how you use npmjs.com. It offers the same functionality to download, reuse your code, and yeah, keep going. So that was a quick demo on the npm part. If I go back to my repository here, I also had a second workflow, which was called publish to GitHub container registry. And this one is a little bit different. This won't take as much time. I will just show you the workflow file, and we will trigger this workflow as well to show you how easy it is to publish a new image. The trigger for this one is a bit different. It listens for a release event of type publish. This means in order to trigger this workflow, I need to create a release and publish that release. And then it will trigger one job, and it also runs some GitHub hosted runner. Check out my repo. I run a few scripts here as well. This is basically to determine which tags to add, version, and these sort of things. And then I run a few other actions by Docker, like key move for setting up like machine emulators, if you're already familiar with that. Build X as well, which is another tool that can be added on top of Docker. And then we use the same two actions that we had in the slides. First one is to log in using a personal access token, which I already have available. And we build and push that same action, right? So if I trigger this one now, which should be as simple as just creating a release, I should be able to find my new image. So let's go to the release. I will create a new one. I will create a tag. And which one was the latest one that we created was 141, right? So I will just say an awesome release. And then describe this release. This also takes, you know, you can add images in here as well. I think I have an image in this repository actually, which is called demo gods. Does that work? Oh, okay. Okay, that's not added. So then I would just add a rocket here for now. And yeah, let's publish. Then we check if that workflow is kicking off. All right, so something is running. This will probably take a bit longer, but it's fairly quick. In the meantime, you can look at the logs and just briefly summarize as well what we have done during this demo. So basically, what you will notice, by the way, I'll stop this from jumping around. What we have noticed is that I've done all of these things without leaving the GitHub, my GitHub environment, right? So speaking of context switching that was mentioned earlier, I can do all of these things without, you know, invoking external tools or when you're logging in with other credentials, doing any manual sort of labor, so to speak. I can just do all of these things in GitHub. So it's very simple and very, it's a very elegant way, in my opinion, to manage and share your source code. And then we saw that this this one here was finished. So that one is green, status success. If I go back to my code, I won't see this one in my repository now because I defined the organization as the owner of this image. So that means that in order to access this image, I go back to my organization. And then we also have a packages tab here, which is called Universe Docker, right? So this is the latest version of my image. And we saw that we created a release from a existing tag that we created when we created a node package. So that one has been added to the image, and also it is auto tagged as latest. Now we also have a code snippet in case you want to use that. But what I wanted to show you was basically the features that we don't have for packages, but that we do have for containers. Now I have this screen might be familiar to you if you already use repositories and you're used to like managing users who get access and which kind of access. I can just do the same for images. So if I wanted to add my colleague here, Rowena, I can do that. So I add her, now she has access to this image. And I don't want her to just have read access, she should have write access. I can also do the same for teams, right? So I think I have a team called devs. Yes, I do. So I add that team, and it's also added. And this is the way that you can, manage your image in terms of sharing with specific people, or you can also make it public, even if this was published from a private repository. So I can just click on make public here, and it works the same way as with a repository, basically. Right, and as with packages, you can manage your versions. So I can go in here, I can delete the specific version, and so forth. All right, cool stuff. I'm just thinking about whether I've missed anything here, but I think I covered most of it. So what I'm going to do now is to just finalize the packages section with this last slide. And I just want to highlight a few things about GitHub packages. Why would you use it? If you already have a package manager, it works for you, you don't have a reason to switch. Well, there are certain benefits that at least I have experienced by having everything behind the same account. And a lot of our customers as well have also experienced the same benefit. It's just less overhead and less like management in terms of spending time on managing different credentials and so forth. And it also eases the sharing of the code. You're already used to sharing your code internally and externally, whether you do like an inner source project or an open source project. And this is, you can use the same GitHub features as you're already used to. You're just kind of extending it to also include your packaged software. And lastly, the integration with GitHub Actions, of course. It's very easy to get started. You can use one of the starter workflows or just build your own. And you can get going in a very short amount of time. Okay, so that's quite a big chunk of info, I think. I think to tie it all together, we would want to get our hands dirty and build something, right? We like to build stuff, and for this workshop, we're also going to build our own workflow. And what we're going to do is to build a CI workflow, and we are going to build a second workflow that package and release our code. We'll be guiding you through this. I'll be going through each step, and at the end of it, we will see the end result. And you will also get to, do this live as well in your own GitHub account, so that you get start building some muscle memory with actions and packages and so forth. All right, so what we're actually going to do. The first step is that we're going to define a workflow called continuous integration, or CI for short, which listens to a pull request. On that event, it's going to run some CI tests across multiple node versions. Rowena mentioned you can use build matrices in your workflow file. So that is what we're going to do. It's also going to auto label your pull request, and it's going to give some, some commenting, some output to the user as well. Like, hey, maybe you want to merge this pull request. Then we're going to merge it, which is going to trigger our second workflow, which will take that code that we put in our repository, package it, publish it with npm, and then it will also create a release where we're going to add a configuration file that kind of automatically drafts your release notes, which is one of my favorites as well when it comes to actions. We mentioned earlier, actions can be used beyond CI/CD, and this is one of those things, right? It's just something that is one less thing to do. I don't want to manually enter all of my release notes every time. Let's just let the bot take care of it. All right, so what I'm going to do is to switch over to my Chrome window again. And this time I'm going to do it a bit differently because I want it to be side by side. So I will first try to carve out a portion of my screen here, and I will have to lean on Rowena or somebody else to tell me if this is looking all right.
It's good.
Okay, awesome. Yeah, what I want to do is to essentially kind of do this in parallel so that I don't have to, switch between all of these different tabs and so on. Let me see if I can get a bit bigger. There we go. All right. So on my left, at this point, I would like to ask you to just make sure that you're logged into your GitHub account. All right. If you're into your GitHub account, please log in now, because we will now go through the workshop instructions and start actually doing some stuff, right? So we're just gonna give everybody a quick moment to make sure that they have logged in, and then we'll get started. In the meantime, I'll have a quick sip of water. All right. So let's go. What are we going to do? Let's have a look at the first workshop instruction file here. We have two of them. Make sure you click on the one that is named Workshop Instructions 1. And we'll go through it step by step. If you have any issues during this hands-on exercise, please give us a shout out in Slack or something like that, and we'll try to get to you as fast as we can. We also have our moderators here being able to jump in and so on. So if you see something is going too fast, or you have some issues, just drop that in the chat and we'll help you out. Okay, so this is the same image as I showed before. So the first thing we're gonna do now is to create our CI workflow. So I have already logged into my GitHub account, which you can see here. And what we're gonna do first is to simply create a new repository. So you can go to your profile here, your repositories, and then you will have this new button. So let's do that. You can use the suggested name, or you can give it your own name. Just call it Universe Automation, just nice and simple. Give it a description. Awesome, awesome automation stuff. It doesn't matter if you set it to public or private. I will just keep it to private. And I will also initialize this repository with their README file. So make sure you got that box ticked before you click on Create Repository. Alrighty. So we have a repo. So let's start digging in. Before we do that, I wanna just mention that we will be doing a few naughty tricks like committing directly to our main branch and so forth. Don't worry about that. If you later on, of course, you might want to set up different branches and so on to collaborate on your code. But for this demo, to keep it as simple as possible and make sure that everything is working fine and so on, we're just gonna be committing some things to our main branch. If your main branch or your default branch is not called main, then you don't have to change it. You would just have to keep that in mind for later on. Whenever you have to specify a branch name, you would just need to make sure that you specify the name of your default branch. All right, so we're just gonna do everything in a GUI, right? I'm not gonna do any terminal commands or something. If you feel super comfortable doing everything in the terminal using Git operations and NPM and these sort of things, feel free to do that. But we're not going to jump back and forth between the terminal during the demo. So just make sure that you have a good handle on how to pull and push and create new branches and so on. But you don't need to use the terminal. You can do everything in the GUI here. So that is actually the first point there in the instructions. If you have Node installed, you can run these commands to do this locally on your machine. But for the purpose of this demo, I would just follow the GUI instructions here. So we'll jump right to this point. So that's why we're just going to start by creating 2 files on our root, right? So I go back to my repository, I create a new file, and I will call this file package.json. And then we have also added some content here for you to copy. And we're going to make some changes to it afterwards, but please make sure you copy this entire text over to your new package.json file. And after you copy, in case you touch something on a keyboard or something and wondering if you have a syntax error, you can click on preview because it will highlight in case you have a syntax error. You should get like a little or something like that. But it should look like this. And we have to make a few changes. So the first thing is to replace the owner placeholder with our GitHub handle or your organization name. You might have created a repository in an organization and not behind your user account. So in that case, you will have to insert the organization name and the repository name here. The easiest way to do this is probably to use whatever is in your URL here. So I will take, this is the owner, right? I will update that. Make sure that you keep the @mention. This name attribute is how GitHub determines where to push the package. So if you don't have the @mention, your publish job later on will probably fail. All right, I'll do the same for the others here as well. We have 3 more placeholders. So I would just replace this. A URL for bugs, and then the home page as well. So I'll just use that same string. And just to make sure that I don't have any errors, I click on preview, looks fine. And then I will commit this, and I will commit it directly onto my main branch. Before we proceed, sorry about that. The NPM package manager does have a naming convention. Before you commit, please make sure that you don't have any uppercase letters in your name. They all have to be lowercase. So if you just copy this URL, for example, which should already be lowercase, but if you didn't, then you, for example, have an uppercase in your handle, like have a big S or something, then you will have to change that to the lowercase. Okay, so make sure that you do that before proceeding, and that is only for the name attribute. Hyphens are okay, no issue.
Stefan, there's a really good question about this package name coming from Bob. He asked, does the package name need to match the repository name?
So you could, if you want to publish with using the GitHub token, then yes. But you could publish using a access token that has access to other repositories as well. And you can also have multiple packages in the same repository. So it's quite flexible in that sense, but for the workflow that we're setting up in this hands-on demo now, it would not work because we use the GitHub token, which does not have permissions for other repositories other than the repository where the workflow is running.
All right, thank you.
Cool. All right, so let's commit this. Great, good stuff. So the next thing we're going to do is to create our source code. This is going to be, you know, if possible, an even simpler example of a JavaScript code. But let's do it. We create that on the root of our repository. We call it index.js. And you know, if you're comfortable with JavaScript, you can put whatever you want in here. Just make sure that you don't have any syntax errors since we're doing this in the GUI. So for now, I'm just gonna add a console log. And I will commit this again to the main branch. All right, so at this point, you should have two files, right? You should have index.js and package.json. And once we've done that, now we get to, you know, the fun part, so to speak, because we are going to add some workflows. More specifically, in the first instance, now we will add one workflow, which is our CI. And we will start off by creating an empty file called ci.yaml. So I will click again, add file. And if you haven't used the GUI before to create files in GitHub, you can add new directories by simply using the /. So like that, right? So the final path should be .github. Don't forget the dot, by the way, it has to be .github. Workflows / ci.yaml. All right. And this one will be empty for now, by the way. So we will just commit this again to the main branch, just an empty file called GitHub workflow ci.yaml. All right, great. So now I see that I have this GitHub workflows directory, and I have my index and my package.json file. All right, so let's start to adding some meat to our ci.yaml file. So I'll go back to ci.yaml. We'll go into edit mode. And now we're going to add the actual workflow syntax, right? And we have done you a bit of a favor and added the content here, right? So if you're in this repository, you expand this part here, you should be able to see what I'm seeing now. And we are simply going to copy this over for now. We will make some changes as well, but this is the base workflow. So I copy, I make sure I select everything. And I add that to my ci.yaml file, right? And one thing to mention that I added to the instructions as well is that if you know YAML syntax, it relies on indentation, right? So you have to make sure that you copy it over as is and that you don't change the indentation, for example, like this, because then it will not work. And you will even get a syntax highlighting like an error, like you see on my screen here, if you do that. So I'll put that back. All right, so we will update the name and I would just call it CI, actually. And then we have a look at what else is here. We have a few jobs. The first job is the build job, which runs on a GitHub hosted runner. And this is how we define a build matrix in GitHub Actions. We can say strategy matrix node version. And in this case, I want to build my code for two different node versions, 12 and 14. I could also build for different operating systems as well that I combine with different node versions. And if you look at the workflow syntax, the help documentation, you will see how this fits together and how you can use this in your own workflow as well. And there's quite a lot of options in there to that offer this flexibility. All right, so this job has a few steps, checks out the code. It builds my node environment using the matrix that I defined above here. Then it runs a few commands, npm install, it runs build, and npm test, right? And if you use Node, you might be familiar with these already. The second job is a label job. And this is where we want to auto-label our pull request. So now that we have built our code, we want to label a pull request. And if you look here, one of the parameters is needs build. And this is quite nice because you can actually define relationships and dependencies between jobs in your workflow. So in this case, what this means is that I don't want to run the label job unless the build job, which is this one, succeeds. All right, so if this one fails for some reason, it will not trigger at all. So this is quite a neat feature that allows you to better control the flow of your automation, right? To define these dependencies. This one also has a few steps, checks out the code, and then it uses a very nice community action, which is called GitHub script. And what GitHub script does is that it essentially allows you to interact with the GitHub API directly in your workflow file. So I don't have to create, like a separate piece of code that runs a curl command or something like that. I can just do a lot of the things that I need to do directly in the workflow file. So in this case, I just define a script attribute, which takes some data here. And the first one is which API do I want to call? And I want to add a label to an issue. And then I define the payload, right? So I have an issue number that it needs. And here I can get the issue number directly from the context, the workflow context. I also need to pass the owner, which repository, and then lastly, which label do I want to add? And in this case, I should add a label, which I name release. If this label doesn't already exist, by the way, it will be created automatically. And then the last job is to actually comment. So we want to say something to the user, right? So a lot of this is the same. We also define a relationship here. So this one will only trigger if build and label succeeds. And it also has a few steps. It uses the same action, authenticates with a GitHub token, and it doesn't add a label, but it creates a comment. So here I can just say like, I passed the issue number, owner, and the repo. And what is the body of my message? So in this case, I say, great job. Whoever this is, this will be me, right? Because I am the logged in user. And I define some static text here. And you're welcome to edit this if you want. Just make sure that you persist the backticks here, right? Awesome, good. Now, actually, that is the entire thing for our first workflow. So I think we are ready to commit. So I will click on Start Commit. And I will commit to the main branch. And that's done. So afterwards, we're going to test it. But first, let's just do a few quiz-like questions here. First of all, how many jobs are there in the workflow? We saw that we had 3 jobs, right, that we added. We had the build, label, and comment job. And the event that triggers this workflow is a pull request, right, like we see here. And the last one, does this workflow use a build matrix? Yes, it does. We define that in this area right here. All right, so let's try and test it. I hope that everyone on the call are following along so forth. I don't see a lot of activity, at least not in Slack, but it looks like people are following along. So great job on that, because now we're going to test it, right? And we need to trigger it. And to do that, we need to create a pull request. So let's do that. We'll also create the pull request directly from the GUI. And I will just create a simple one because it doesn't matter, you know, which file I change or something. So I'm just going to change the README file here. I'm going to click edit, and I will say this should trigger my CI. And then I will not commit to main, but I will commit to a new branch that I call update README, right? And then we have our actual pull request here, and I will just add, why not add a, yeah, I like the ship it squirrel. So let's add that one. Alrighty, so now we have our pull request, and in a moment, I should see this GUI being updated. Yes, okay, there we go. And you should see the same in your pull request. You should see these two build jobs popping up. Why are there two? Of course, because we defined a build matrix for two separate node versions. I can also see how these jobs are progressing by looking at the checks tab. I don't have to go to the actions tab in the repository. I can just go to checks here in the pull request. And now we also see, I think I need to zoom out a bit because now, yeah, okay. I hope it works for now. But we saw that we had the two build jobs, they succeeded. And we had a dependency from the label job to the build job. So that is why you can see this one kicking off only after these one have succeeded. Maybe it's a bit of a delay in the GUI. And once this label job is complete, then we should see the comment job starting as well. So while this is running, I think it's maybe good to just have a few seconds pause here anyway. So make sure that people are keeping up. Roven or Thomas, give me a thumbs up or thumbs down in case people are.
I've been following along, and I can see the really cool visual right now. It's really nice to look at. Right. Yeah, feel free to keep the questions coming. Maybe it might be hard for you to type a question and also look at Stefan. So we're going to pause here a little bit just to give you an opportunity to ask questions. Feel free to give feedback too. We're open to that all the time.
Yeah. So, yeah, exactly. So drop your questions in there, keep them coming. In the meantime, though, we can see that this workflow has succeeded. So all green, right? We like green check marks. And if I now go back to the conversation tab, I can see a few things happened. I can see that I have a new label called release, and I can see a comment, right? That was the last job that ran. So great job, my handle, you'll see I passed, and so forth. So if your workflow failed for some reason, so if you have any red crosses showing up here, anything that indicates that something is wrong, you know, drop something in the chat. Please add a screenshot or something as well so that we're able to help you out. But for now, I will continue as well, and our moderators will support you in case you have any issues. All right, so we will not merge this pull request yet. All right, so we leave this one as it is for now, and we're going to jump over to workflow 2. And this is the last part, and it's a bit shorter, but we're going to commit what we're adding now, which is our second workflow, right? So if I just show that picture again, just to show where we are. What we did now was we completed this part. We have not merged our PR yet because we want to add this workflow first. And we're going to set up a package and publish job and also create some release notes. So let's get started on that. In order to do that, we need to add another workflow file in our directory. And this one we are going to call GitHub workflows release.yaml. So I'm just going to copy this name right here. To go to my release directory. I will add the file. Release.yaml. Please don't forget the YAML extension, the file format. And we'll do the same as before. We have some a code snippet here that we will reuse. And we'll have a look at the different components in this workflow. So here we have our second workflow, right? So this is the main workflow file. And what this workflow will do is to publish and release a package. It listens to one event, which is push, but only if the push event happens on a branch called main. So this is why I mentioned earlier, if your default branch is called something else than main, then you need to update that name here to if it's still called master, for example. By default in GitHub now, all new default branches are set to main. Default branch names are set to main. But if you have something else, make sure you reuse that name here. So this one also has a couple of jobs. First one is to update the release draft. And this one will essentially reuse an action called release drafter. We have a link here as well in the instructions where you can have a look at the description of how this actually works. We use this as well in GitHub. I have used it before as well with customers and so forth. It's very powerful actually in terms of its configuration options, and it saves you a lot of work when it comes to like setting up new draft releases and these sort of things. So you can find the source code and everything using this link. All right, so going back to the actual workflow file, what does it do? So it used the community action, and then it's going to set up the release draft according to this config file. And this one we will add in a moment. We only need the GitHub token, so we don't need any personal access tokens here. Just use that to authenticate. And the last job is going to publish a package, right? So here we also set a needs relationship. It will not kick off unless this job here succeeds. And then in the demo before, sets up our node environment and then publish the package. So great. And then I have actually selected the wrong branch, I see. So what I can do, if you're in the same position as me, where you can no longer choose which branch to commit to, because I want to commit to the same branch that I created earlier, the update README branch, right? So I would just copy this for now without confusing everybody. I will go back to my code. I will leave that, and I will select this other branch here. So now I'm in my update README branch. You could also just commit to a third branch if you wish, but I want to follow along with the instructions here. So I just go back to my workflow. I add that file again that was called release.yaml. And I basically just copy that in here, right? All right, so now I can commit to the update README branch. All right, so I'll commit that. Cool. The last thing that we need to do before we actually are done with our little hands-on here is to add the config file. And this config file does not live in the workflow directory, but in the GitHub directory, as you can see from this path here. And this is the file that is used by this action to determine, so how is the, what should the release draft look like? You know, which components are in there and so forth. Now we'll create a new file here. I will call it release drafter.-drafterconfig.yaml. And we also have some content here to copy. And if you want to learn more about what these different attributes actually mean, you can go to the link that I showed you earlier, and you can see all of the information in there. Alrighty, so we now have a config file, you don't actually have to change anything. I mean, if you know Markdown syntax, you can add some subtitles and stuff like that. But I would recommend for the purposes of this, just quick demo to leave it as it is. And I will also commit this to the update README branch. So I commit that.
Oh, I just want to add that a config file is not always the case for every single action. It's just this one particular action that was created by the creator. They decided to have a config file that comes with it. So this is a special case where sometimes some actions come with a config file.
Yeah, thank you. Yeah, that's a good point as well. You can make it more minimalistic, let's say, if you want to, right? All right, so we have now actually set up our workflows. I also see that because I pushed here to this pull request, I'm running my CI again, which is, you know, probably what should happen, right? If you have a CI workflow. But I will wait until this has completed. And then I will merge it back onto my main branch. So now I'm on the update README branch, I'm in my pull request, and let's merge this. And this should trigger the release drafter. And after this action is done, you don't have to delete the branch, but I think it's good practice. So let's delete it just for some house cleaning. And now if I go to my actions tab here, I should see another workflow. It's my publish and release workflow, right? I go to that. You can now see, since we have more jobs here, you can see how this visualization works as well. And once this is done, I should see a few things happen in my repository. The first thing is that I should have a package that is released. And the second thing is that I should see the release draft. And this release draft should be formatted according to my config file. So we will see if this is coming along nicely. Looks like it is. In the meantime, again, maybe good to have a bit of a breather, make sure that everyone is following along. All right. So this one should be fairly quick. It's not a lot of source code to publish. So there we go. Completed in a few seconds. Okay, great stuff. All green again. I think we're on a roll. So we go back to our repository, right? And then we see on the right-hand side, hey, we have a package. There you go. And then you can see exactly the same as I showed you earlier in the demo. You can navigate here, you can manage the versions. Now you just have one version. But yeah, it looks like that went really well. And when it comes to the releases, you also have that on the right-hand side, right? But don't be worried, since it's only a draft release, it doesn't show up in this overview. You have to click on the release link. And then I can see here a few things. I have a draft, which has a headline. You did it. Great stuff. And I can also list all of the changes included in that release, which essentially means all of the pull requests. So this one is automatically adding a list of bullets with a link to my pull request, right? So this is really useful, especially in larger projects, in open source projects, or whatever it might be, to always have that coherent release notes, right? And you can do all kinds of stuff with this as well. Like if you have very well formatted commit messages and pull request names, you can essentially just have a full-fledged release with the notes without doing almost any of the overhead. You don't have to do any manual typing and stuff like that. So this is really something that saves time for the team. Yeah, that was just a link to the pull request, which I merged. Awesome. All right. That was actually the end of it. I am conscious of the time as well. And we do just have a couple of more things that we want to mention before we wrap up and address any questions that might be left. Later on, you can have a look at this additional exercise. By the way, there are a few configuration options in the config file to, define your release drafts any way you want. So have a look at that later as well if you would like to work more with that. Cool. Okay, I hope that was useful. I would just have to, okay. Trying to stop my sharing here. So.
You see your presenter side of your slides currently?
Yeah. So apparently, I can't access this stop sharing. Okay, so I will just start it over. And so I'll go back to my Zoom and then I will share my second screen. Sorry about that. All right, desktop 2. Share. Okay, that should do it, right? Now you should see my slide again. So great job. I hope everybody came through that unharmed and that your workflow succeeded. Please let us know in the chat if it didn't. Thank you very much for going through that. I know that was probably a lot of information as well. We're getting to the end of it now. So Rowena and myself just want to, leave you with a few pointers before we address any questions that might be left. So I would just hand it back to you, Rowena, to take us through the last notes here.
All right. So let me share my screen again. Yeah, so just a quick summary of what we have achieved today. We saved some time and talked about how automating can help reduce the risk of human error and just generally just make your life a lot easier. We talked about how workflows are triggered by events. We walked through all the components of GitHub Actions. And don't forget to leverage the work that's already been done by the community. Again, GitHub is known for its open source community. Definitely use that to your advantage. Why build something that's already been built by someone else? We talked about using secrets. And finally, we talked about GitHub packages and how you can publish your code with GitHub packages. And so if you're curious about what's up and coming for the next steps for all these features, we have the public roadmap that you can definitely go and check it out. The link is in here. And don't worry, the slides will be shared with you after the call as well. And so you'll be able to click onto the slides. We also have a change log that we keep track of all the changes that has happened. So if you're curious about what kind of changes have arrived to GitHub, you can go and check out the blog as well. So with that, we'll wrap this up. I definitely want to thank all the moderators we have on the call. They are also our mentors. So thank you so much, Thomas, Tiago, Evgeny, and Stowe. Thank you so much for your help. We still have some time left, so I definitely want to leave this time to open up for any questions that you might have. Yeah, maybe I can exit.
Yeah, there are a couple questions in Slack right now that I guess we can answer live maybe instead.
Sure.
So one came from Tio. It says, first of all, this was a great session, so thanks. And then I'm wondering about the privacy of packages within an organization that has teams. So if a team wants to have a secret NPM package, are they able to do that? If so, how?
You want to have a secret NPM package. Is it a private package that you mean? So if you want a private package, then you can certainly do that, because the only thing you have to do is to build a package from a private repository. In terms of a secret package, that's not, maybe it's a terminology thing, but at least it's something that I find difficult to perhaps get a full grasp of what you mean.
If you don't have access to a private repository, you don't have access to the package either, correct?
That's correct. Yeah.
Yeah. So if you had a private repository within your organization that no one can pull from, I guess they won't be able to access the package, right?
Yeah, it depends on the organization setup, because what you do essentially, if you have read access to a repository, you can also pull the package, right? So if you have an organization, then definitely it ties back into your permission structure within the organization itself. So if you want a secret package that nobody knows about, then yeah, you would have to kind of marry that up to your permission structure in your organization. It is possible for sure. But yeah, there are just multiple things to take into account.
Yeah, and I do know on the public roadmap for packages, there are a few items about more granular permissions in general coming down the pipeline. So we should see more towards that, because we definitely know it's an access control question. So the next one I saw is, let's see. Okay, Edward asked, I'm curious about the management of non-regression tests and their results. Looks like Evgeny's starting to ask some clarifying questions there, but if we're talking about like unit testing, maybe performance testing, like things that aren't just checking your sanity checks for regression, or your smoke test for that.
Yeah, I mean, for non-regression testing, this question has also come up before. So in non-regression testing, it's also multiple things, right, that people can mean. So for some people, it's a matter of performance testing, things like that. And essentially, you can do a lot of these things with GitHub Actions, but it is a little bit dependent on the context, because if you have done performance testing, load and performance testing, for example, in enterprise grade software, is not a trivial task, right? So if you want to kind of migrate from whatever you're having today into actions, then it does require some architecting and some thought. But if your tool has an API that can interact with actions, then yeah, you could do it. I haven't seen too many publicly available actions that are kind of like, specific for non-regression or performance testing or stuff like that. But I think there will be more and more of it coming up in the future. At the moment, we have like 6,000 actions on the marketplace, and it's only growing. So keep an eye on that.
Awesome, thank you. I think another good one, it was answered in the chat, but I think it's important to call it out. So if a workflow fails in the middle of a run and has already tagged the repo in previous steps, for example, is it going to converge when I rerun the workflow? And how does that work? And I could read the answer we have initially to kick it off if you'd like.
Yeah, sure.
Yeah, so Tiago initially answered it for us here. So a rerun is always going to run with the exact same commit SHA. So there shouldn't be any type of like merge conflict issue or anything like that, right? It's just going to kick off the job with the exact same information.
That's correct. Yeah. It is a good point though to bring up, because exception handling in actions is actually, I mean, it's a real thing, right? So it's one of the aspects that should be taken into account when you are building your workflow files. I have had this experience with some customers as well, that you start to build an action, and just for the convenience of it, you kind of, start doing everything in your JavaScript action, and suddenly you have kind of like this bloated action that does a lot of different things, but it makes the exception handling and the debugging more complex in the end. So in terms of exception handling, it's a lot cleaner to have these different actions that can exit with different states, right? And you can react on these states as well, so that you don't have like the whole thing triggering, performing a lot of operations on your repository, adding teams, all of the things that you can do with actions without having like an exit point. So it's actually an argument for kind of trying to modularize your actions in a sensible way, so that you don't have to do all of these different things in your repository, and then the last step fails, right? And then you have a lot of cleanup work to do.
Yeah, definitely agree. I think Rowena touched on it with the chainable versus monolithic actions, and just kind of that separation of concern, and really having like one action that does one thing very, very well. And that way, if that one individual step fails, you know that that's the pain point. And you don't have maybe a giant action that does your entire release process, sends out a tweet to Twitter saying that I released something, and orders a pizza from Domino's. So, you want to have those individual steps like that. Cool. So another question I think would be important to call out is around billing for GitHub Actions. So what happens if I finish my included minutes, either as an organization or a user? How does that portion work? And Stowe's already been answering that for us here, but just to kind of publicly state it here on the call, or on the webinar, excuse me. As an organization, first of all, you can set limits on like how many extra minutes you want to be able to purchase, basically. And then, that way it'll continually charge up to that point for you, basically. But remember that for public repositories, you have unlimited minutes. So this is only going to be for any of your private repositories.
Yeah, exactly.
And let's see, we got about 4 minutes left. So
Bob asked,
what else we got?
Is there a place where feedback can be given? I actually don't know. Is there going to be something that gets sent out, or we'll still be looking at the Slack channel. So if you want to say something, feedback, anything at all, I mean, we're reading it now. I don't know if there's anything official going out.
Yeah, we love feedback, and of course we love your input on how to improve some aspects of our presentation and a workshop, whatever it might be, right? Maybe we'll make sure that, you'll have a channel to provide feedback and so on, and we'll loop back after the session to see how that works. You already received an invite, right, for this workshop, so we already have an email address to send this to. And I have to lean on Faith, who's also in this call for that, but yeah, we'll loop back on that after the workshop.
Yeah, and I just thought of one other note regarding the like monolithic versus a chainable action is another interesting process, or maybe a good process for maintaining these workflows would be you can export your logs as well from actions. So there is that live streaming that we saw in the UI, but you can also export those and save them off separately if need be, and then load them into something like Splunk or something like that for long-term storage if you wanted to do that.
Yeah, that's an excellent point. Exactly. So we kind of scratched the surface today, but if you look into the documentation, a lot of those resources are in the workshop repo. If you click through those, you will get a better sense of, all of the different the corners of GitHub Actions and packages, and it's very flexible. And just one use case, like Thomas mentioned, exporting the logs and so on, is just something that is obviously super useful, but we didn't have time to cover it today, so we can only encourage you to kind of dig into that using our documentation and all of the good information that is out there about actions.
So there's a couple quick questions coming in the last couple of minutes here. So maybe just to kind of rapidly answer those ones. Ivan or Yvonne, I'm sorry, I'm not sure which way you would pronounce it. Are there any visualizations coming to YAML changes similar to Azure Build Service? So I know, I think 3 days ago, we just announced a beta on day 1 of Universe of visualizations to see like your visual pipeline. Like Rowena had mentioned Blue Ocean and Jenkins, for example, you can see kind of your branching pipeline across the screen. That is a beta you need to opt in for. And then let's see, for YAML itself right now, there actually is some smart syntax in there that will highlight if you have errors and things, or it'll help you kind of auto-populate, and the docs are built into the web UI editor. So you can actually just copy paste things over and find references that way. So hopefully that answers that. Let's see, there was one more I saw in here. The recording for the session, do we know where that's going to be posted?
That will be circulated using the shared via email.
Okay.
That was on that kind of banner when you joined this workshop. It was on the, maybe everyone didn't see it, but it will be, you will get that link.
Perfect. Okay. There was another question from Todd that was talking about Jenkins earlier, and just kind of our opinion on actions replacing Jenkins, Circle CI, Travis, things like that. I think in a general sense, we see actions as being a competitor, and we do have people that are migrating off of Jenkins into GitHub Actions or Team City or Circle or Travis. We have some public docs actually on migrating from those as well, and kind of comparing and contrasting the difference between those. You know, it's not a full feature parity yet, but I think that is kind of the idea, is that we're going to have this full CI/CD pipeline. And then in addition, Actions is going to GitHub Enterprise Server, which is our on-premises model as well. So as that comes more generally available, I think more people are going to adopt it, and we might see a shift from Jenkins. So we'll see.
Yeah.
We're still happy with Jenkins too, though. So I saw one more, I think, but okay, there's some feedback coming in, which is great. Thank you for that.
Oh, I just saw one. Someone asked, Ivan asked a question about Azure to GitHub Action. From what I can gather coming from Azure is that Microsoft is going to, essentially the features are going to be, how should I say this? Without, like, I have a graph that I usually talk about this, but essentially Microsoft is going to continue to invest more in GitHub Actions. And it's not about whether you should go with Azure or GitHub Actions, it's when you should migrate off of Azure, because eventually in the future, it's going to be, the focus is going to be GitHub Actions over Azure.
Yeah, I just wanted to reiterate what Thomas said already. If you go on to our documentation page, you will also find migration guides for migrating off of Azure pipelines onto Actions. So same as with Jenkins or Travis CI.
Well, with that, we're at time too. So thank you, everyone. As it says on the slide there, that was perfect timing.
Awesome. All right. Then I guess that all that is left for everyone to do, Rowena and myself, all the moderators, all of you participants, not the least, thank you so much for your time. Know that we had a blast and hope that you had the same. Rowena, any parting words?
I could finally relax. I've been sweating, so I can just relax now.
All righty. Thank you all. Enjoy your weekend and have fun with Actions.
Yeah. Thank you, everyone.
All right.